In this topic, we are going to cover BeautifulSoup. Web scraping is the process of copying and extracting data from websites. And web scraping can be useful in hacking to speed up the enumeration or brute forcing process. But web scraping can be difficult due to the unstructured content of web pages. We just get a blob of HTML and need to extract the pieces that we are interested in. For a person, and thanks to browsers, you can usually do this by reading the website. But converting this high-level process straight into Python can be more difficult. Web scraping can be approached with 3 steps. First, download the HTML for the page, then parse the HTML, and finally, navigate the parse tree to extract the data we are looking for. This can be more straightforward for some sites that offer APIs which we can interface with, but for more complex sites which don't offer an API and which have different structures, BeautifulSoup can help us out. BeautifulSoup is a library that makes it easy to perform web scraping because it understands HTML. So to practice web scraping, let's start by using requests to download the HTML of a page. And we covered how to use the requests library already in the Python 101 for Hackers course. And for this lesson, let's scrape the 247ctf.com scoreboard. So let's first navigate to the scoreboard so we can see what we're dealing with. Let's import requests and save this. BeautifulSoup.demo.py. And now we can use requests to download this scoreboard. And we can print out the text. We can execute this. And we can see that this DOM is much harder for us to read and understand versus the rendered version here within our browser. And we could try to parse this HTML using a regular expression or some other hacky approach, but this quickly becomes unmanageable as sites or requirements change. And so for example, what if we wanted to create a script to track the top players at 247CTF? If we look at the 247CTF scoreboard page, we can easily see the scoreboard and top players, and using inspect element, we can also see the HTML structure of the scoreboard. So we can right click here, inspect, and we can see how this table is structured for each user. So for the first place player, we can see their ranking, their avatar, their name, their country, their points, and their status. And BeautifulSoup allows you to interact with HTML in a similar way as we are interacting with the web page here using the developer tools. So let's install BeautifulSoup using pip so we can use it in our project. Pip install BeautifulSoup 4. And now that it's installed, we can import it from VS4, import BeautifulSoup. And now that we've imported it, we want to use BeautifulSoup to parse our HTML. So let's do that. Soup equals BeautifulSoup. And the first parameter is the HTML we downloaded, while the second parameter is for the parser we want to use, which in this case is HTML. And we can print the raw text content of the web page without displaying the elements using soup.text. Let's comment out this print here. Execute this. And now we can compare the output with the page. And we can see the text here as expected, but still in not an easy to use format. And we also have other functions available to us as well. So we can print out the title of the page, execute this, soup.title.string. And here we can see the title of the HTML page, which we can also see here, as well as the raw text string, 247ctf-scoreboard. And we can also use soup.find to find HTML elements. So we might want to find the first link. And we can see that the first link which has been identified is for /dashboard. We can verify this as well, /dashboard. Or we might be trying to find all links on the page. So then we could use find all HTML links. And we can print out the link in this similar format, or we might only want to print out the href, so where the link is sending you. And here we can see that Beautiful Soup has parsed the HTML, identified all of the links, and extracted only the href component. And this search process works for any type of HTML tag. Basically, Beautiful Soup converts the complex HTML structure into a bunch of Python objects, which we can then query and interact with based on the structure of the HTML tree. And we can include extra restrictions on the searches that we use. So for example, we might want to print out an ID with a specific tag. So fetch-error, for example. Or we might want to print out specific class. And we need to include the underscore here because, as we know, class is a special Python keyword. Or we might even want to be more specific. So we might want to search for a link which has a specific class. We can execute this. And here we can see we've found the ID that we're searching for in this div. And we've also found the elements with this specific class, which we also searched for. And so back to our problem statement, how can we extract the specific rankings for each player on the scoreboard? Well, let's first identify the scoreboard here. So we can see that the scoreboard is a table. So let's start by finding that table. So we can use soup.find table. We can verify this as well, that we have the right one, because for example, there might be more than one table on this page. And we can see here, based on this output, that we've found the correct table that we're searching for. And now we can dive deeper down into the structure of this table. So after the table, there's a T body. So let's extract that. Table body equals table.find T body. And then within the T body, we have a number of rows here. We can see we have a row for each user based on their ranking. So we can find all of these rows by searching in the table body. We want to find all of them because we don't just want to find the first placed user, we want to find everyone in the top 50. And now that we have our rows, we can iterate over them. So for row in rows, we can verify our information here. Let's print out each row. Let's execute this. Let's add a delimiter here just to make this a bit clearer. So here we can see the row for this user. Here we can see the row for this user, and so on. And within each row, there's also a number of columns. So we can see that for each of these TDs, we can see different data in each of these columns within the row. And so we can extract the data within each of these. So we could say cols equals x for x in row dot find all td. And we could print out our cols. And there's still a lot of HTML structure noise here, but we can get rid of this. So we could just look for the text, and we could also strip out the white space. And now we can see that our structure is starting to take place as we've now extracted the information which is being displayed to us here. So we can see the first place user, the second place user, and so on. And with this new structure, it's quite easy for us to work with this in Python to solve our problem. So we can say person is in place with points, and we can format cols 2, 0, 1, 2, cols 0, and cols 4, 0, 1, 2, 3, 4. Don't need points here. We can execute this. And we can see that we've now extracted the information from the scoreboard. And as you can see, BeautifulSoup is a powerful web scraping tool that can help you extract structured information from websites. It's important to note that some websites won't like you performing scraping, and there are a number of giveaways in our request that give us away, such as the requests user agent header when we extract the page here, which we can change, or depending on what you're doing, you can also limit the number of requests that you're making. So for example, by including a pause or sleep if scraping multiple pages. But that's it for now, and in the next lesson, we are going to cover pi to exa.